Okay, so for the first one, actually, did everybody get A right? Most people get. All right, let's start with A. Let's start with A. All right. So you always start with what you are given, which was the 4.50 grams of H2O. Write in your units. Take the extra literal 2 seconds to write 4 extra letters. Okay, or 5, whatever. Take the time to do it. Your unit multiplier. We set up our unit multiplier, and the first thing you should ask yourself after you draw those little railroad tracks is, what am I trying to get rid of? So what am I trying to get rid of here? Grams. Where does it go? On the bottom. Don't even think about a number until you get your units right. Write grams of water. What am I trying to get? Moles. I know, because I should have memorized in my study, and I should have memorized that 1 mole of something is always its atomic mass. Always, 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 always. Its atomic mass, molecular mass, whatever. Just add up the mass of all the elements. And that's equal to 1 mole. All right? So, how many grams of water are in 1 mole of water? 18. Where did that come from? Atomic mass of oxygen is 16. The 2 hydrogens is 2. 16 plus 2 is 18. Okay? Now that I have this set up, I can very easily, I can just look at this. I don't even have to think. Okay? Which, when you're on a test, we don't want to spend time doing that. We want to be able to have this down pat so we can move quickly. Grams cancel out. I multiply across the top and I divide by the bottom. 4.5 divided by 18 is what?
0.25.
0.25.
Dr. Holloway.
Okay? Now, the other reason I want you to do this, one, it helps you to see, hey, I know I'm getting this right because I have moles of water. I know I multiplied and divided correctly. The other way is you do this the same for every problem. I don't care what compound it is, you do the same thing every single time. Which, if you have a process that you do it the same way every time, again, when you get on a test, you don't have to think, this is different. We do this one or this one, or it's just like natural. And you can move through that quickly. Okay? So, the second problem. We start the same way. So, somebody tell me, here's what I want you to do. Somebody tell me what you wrote down for number 4. I don't care if it's right or wrong, because we can learn as much from a wrong answer as we can from a right answer. So I'd actually prefer somebody who didn't get it right to tell me what you wrote down. That guarantee everybody else is doing the same thing. Okay? All right. So what did you write down? What did you start with?
471.6 grams of barium, whatever the
Hydroxide. Yeah. Okay.
And then the railroad
tracks. But for the atomic mass of the compound, I had 154.3378.
There's our problem. Okay. The atomic mass is supposed to be 171.3. Here's how we got that. We have 1 barium, which is 137. We have 2 oxygens, which is 32. And we have 2 hydrogens, which is 2. So it's 137 plus 32 plus 2, which is 171.3. So how did you get your 150? Would you say 154?
Yeah, I think I just did 1 oxygen and 1 hydrogen.
Okay. Exact same thing they did in the second period class. See, everybody's, but that's what we got to figure out. That subscript of 2 means that it goes with everything inside that parenthesis. So there are 2 oxygens and there are 2 H's, and you have to account for the mass of all of them. Okay? And so the atomic mass, when we add it up, should be 171. And then we're just gonna, that's how many grams are in 1 mole. And then what are we gonna do? We're gonna multiply top, we're gonna divide by the bottom. So 471.6 divided by 171.3. What do you get? 175. Okay? So has everybody seen where you messed up at? Because you need to know, you can't fix the problem if you don't know there is a problem. And finding it out on the test is a bad way to find out there's a problem. You want to know that before the test. Okay? All right, so what I want you to do is I want you to try C. Now that you know what your problem was in B, try to do C again. And you have the correct answer, so try to do C again.
You said that sometimes there'll be like a difference in the numbers if you round different, so how big is 2 different? I got like 0.4 if I round.
That is okay. So if my answer, if your answer is just rounding it up, that's okay. But if you get something like 1 or 0.7 or, that's,
The number's like 0.3984, or like.
that's okay. That's probably okay. Okay, it means I have put it, there's 4 there, plus times that 2, that would be 4 times 2, which is how many? 8. 8. All right, so in C, tell me how many irons are there in that formula? 3. How many phosphoruses are there? 2. How many oxygens are there? 8. There's 8. So that's what you have to figure into your molecular mass. 3 times the iron, 2 times the phosphorus, 8 times the oxygen. Okay, so if that's what's throwing you off, that is the easiest fix in the world.
That's one of the big ones.
And that's a big one. But it's easy to fix, and it's not hard. It's not like you're trying to learn some hard new concept. You added the 2 instead of multiplying. You multiply the subscripts, you don't add the subscripts. So, what did y'all get for the atomic mass of the iron phosphate? 357.5 or 0.49. 357.49. Okay, so if we set that up again, tell me what I'm going to do to set up and solve this problem. Okay, I'm going to put moles on the top and grams on the bottom. Take the time, as aggravating as it may be, take the time to write the formula. So, how many grams are in 1 mole? 357.49. So what am I going to do now? Multiply top, divide by the bottom. So 129.68 divided by 357.49. 0.36. Now, is that hard? No, it is not hard. It is not impossible, is it, Braden?
No, actually,
It is not that bad. Okay. All right. Okay, so before we go to Unit 5 stuff, let's go back to Unit 4. Come on. Two things I want to mention to you that hopefully you will like. I don't know, maybe you won't, maybe you will, I don't know. All right, so point number 1 that I want to mention to you. You are able to open up your test and you are able to see the correct answers. The math problems and the long-term response do not have the correct answers put in there, so you can't really find it. And if you look at, can't really find it. But here's what I'm going to allow you to do. It says you have, it may say you have a second attempt, you actually don't. That was my mistake from a mess up I did with second period. But here's what I am going to let y'all do. For the math questions, that's 16 through 21, you may do test corrections on those 5 problems? On those 5 problems. Here's the way you're going to do your test corrections. You, on a piece of paper or a Google document, you will tell me what you did wrong. And you can't say, you got the answer wrong. I want you to tell me what mistake did you make in doing the problem. Okay, wait. You got to tell me what you did wrong. I got the wrong molecular mass. I set up my unit multiplier backwards. I did this or whatever. So you got to look at your work. Tell me what you did wrong. Do it correctly and get the right answer. Redo it and do it correctly. Okay? And then you'll turn it in. You can do it on a piece of paper or you can do it on a Google document and email. It is due, you listen, it is due Monday. Okay? So those 5 problems. I want, yes, this Monday, the one coming up. So these 5 problems, I want you to go back to it. Now, you can go back and watch all the review videos, all that, because we're on that long-term response. I have a review video for, it's not quite word for word, but it's pretty close. Okay? Go back and watch all the videos. Go back and look at your problems, because there's molecular mass practice problems, percent composition practice problems. They all had the correct answers at the bottom, right? This is why I told you had to show your work. So check your work. Make sure it's right. Make sure you know how to do it. And then redo it.
And we have to go back into the lockdown browser.
You'll have to go back into the lockdown browser and all that good stuff to see the problem. It's due on Monday. No. So, here's the second thing. So that's one way to get yourself some extra points. Here's the next way to get yourself some extra points. Are you listening? Wednesday, we have a Google Meet. Every single Wednesday at 10 a.m. We have had for the last 9 weeks or more. Come to that Google Meet with a specific question that you need answered. Whether it's about the test, about the lab we're going to talk about anything we did in class that we're going to do in class today, come with a specific question. By specific, I mean not, I don't understand any of this. That's not specific. I mean, I don't understand how you got the answer on number 17. Can you explain how you got this? A specific question. Come with a specific question. When your question gets answered, you get your extra credit points.
How much?
I haven't decided yet.
Well, I'll see it.
Is it on the test or is it just go in as
Anything you don't, what?
It's like the extra credit we're gonna do it on this test or?
Yeah, I can put it on the test.
Oh, sweet.
Yeah.
Sounds like a much.
Let's see. If for some reason you can't make it Wednesday at 10, I will be here at school at 7:15 in the morning on Thursday. You can come by then. I'll let you in the library and we'll work it out then.
Wait, is 10 our class period or like the whole 10th grades?
10 a.m.
It's like, is it our class
No,
period time?
it's everybody in creative.
Yay.
Oh.
But if history serves right, there won't be that many people that show up. Which is why I'm getting you to do this now. Because we had one last week before this test. Nobody came.
You offered
Nobody asked me a question. Nobody said anything.
We all know.
Kevin didn't fail.
Not all of us, no, all of us did not fail. All of us did not fail.
Kevin actually does this work.
Here we go, look
I
at
think I
how
went 2 and I read
I'm
65.
trying, man.
Alright.
I didn't say
But,
I just saw.
but you made one mistake, now you know what your mistake was, you can go back and fix it. And you won't make that mistake again, right?
Is the
So, that's what we need. That's what you need to figure out, that's why I'm making you do this, yes.
Is test corrections like half credit or full credit?
It'll
Like how?
probably be half credit, yeah.
And so we can only do one through like.
You can only do 16 through 21.
And
The
not,
rest are multiple choice.
you don't need to email this paper to me.
Okay.
I will take either one.
Okay, thank you for this paper.
Wait, is it?
But we're not working on it right now.
Oh, yeah, I know.
Hey, does it tell us if we got 16 through 21 correct?
Yes, it will tell you. So the way, on those way I have this graded, listen, if you got full credit, of course it'll say 3 out of 3 or 10 out of 10 or whatever. If you gave me an answer and no work and your answer was wrong, then that was a 0. 0 out of 3. If you gave me an answer and it was right, but you didn't put any work, I gave you 2 out of 3. Because I need you to show your work, okay? If you got one little thing wrong, like a incorrect molecular mass or something like that, I gave you 2 out of 3. If you got one tiny little thing right, like molecular mass, but everything else was wrong, I gave you like 1 out of 3. So depending on how much of your work you got right, that's how I scaled your points. And it'll tell you on there 1 out of 3, 2 out of 3, 3 out of 3. Okay? All right?
At the meet, when we ask our questions, can we leave or do we have to stay?
When you get your question answered, I would recommend that you stay or that you use that time wisely, because that's what it's there for. It's there on that day for you to ask any questions that maybe you don't want to ask in class, because you don't like asking questions in class, or that you don't have time for. Come then, and it's just me. Me at my house with my dog. That's it. So I'm sitting there for an hour, waiting on y'all to ask me a question. So come and ask me a question. All right. That won't get you extra credit, but I appreciate your concern. Okay, so let's talk about the empirical formula lab. So go ahead and go to the 19th in Unit 4. Go to the 19th in Unit 4. Click on Empirical Formula Lab. You will turn everything for this lab will be turned in right here at this assignment on the 19th. I already have a few people that turn things in, but you're going to have to wind up doing it over. So, all right. So you have a Google Sheets, and I have a video of how you're going to use that Google Sheets. You're going to give me a graph, and this video explains how to make the graph in Google Sheets. It's really pretty easy. Okay. And then down here, you have your student data sheet and your POGL. Your student data sheet is what you're going to use. That and the Google Sheets is what you're going to use to write your report, your formal lab report. Here is the rubric for the formal lab report. So you're going to type this up in a Google document or however you a Word document, okay? These are what you get points for. You want to get the most number of points, obviously. The neat and organization thing ought to be a gimme because y'all are all typing it out. So hopefully you can at least put words together and make a sentence and, not give it to me in yellow font or something weird that I can't read. So that should be 4 points, easy. Title and date, literally put the title, Empirical Formula Lab Report, and put the date. 4 points. Can't get any easier than that. Purpose. Your purpose is going to be the essential question that is in your student document. Okay, it'll say, a big heading in the document, essential question. You will take that question, turn it into a sentence, and there's your purpose. Just take it from a question to a sentence. That's your purpose. So that should be an easy 4 points. The data is what's in this Google Sheets. Now you can take your data table and literally copy it into your document, or you can attach a link to your Google Sheets. I don't care how you do it, as long as I am able to see your data table, okay? That should be an easy point, unless you don't finish your data table, that should be easy points. Procedures, these are also in your student document. It has a list of like 14 procedures. Here's what I don't want. I don't want them copy and pasted. Don't give me number 1, number 2, all the way through number 4. I don't want that. I don't need all that. I need a detailed summary. Okay? So the way I explain it in second period, I need you to be able to write this report out, give it to Mr. White or Mr. Mason or some other teacher or some other person, and then come in here and do the lab. Okay? So it doesn't have to be exactly like theirs. You can summarize it a little bit, but I need them to be able to come in and know what they were doing. Okay? Somebody who doesn't know science, who isn't in your chemistry class or whatever. Okay? Calculations and graphs, that's going to be your Google Sheet too. All your calculations for turning grams into moles, for doing percent error, for the graph, all that needs to be in the report. You can keep it in put it on your Google Sheet and just attach the link. That would be the easiest thing to do. Or you can actually type it out in the paper. Okay? Conclusions. Your conclusion needs to line up with your purpose. So I think the essential question is to see how chemical formulas are developed or something like that. Your conclusions need to say, through our experimentation, we discovered how chemical formulas come about, blah, 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 okay? So it kind of needs to answer, your conclusion needs to answer the essential question, okay? Discussion of theory addresses the theory demonstrated in the lab, which is, again, empirical formulas and all that kind of stuff. So you'll just talk about those. Error analysis, that's part of your calculations. You're not going to get it perfect. You're not supposed to get it perfect. Okay? So you're going to do a percent error, and you're going to need to explain how you got your percent error, and then why you messed up. I mean, if you wound up with 30% error, that's not really good, okay? You need to have a low number for that. So come up with a reason why that happened, because, stuff happens. But you can't just say, I don't know. You got to figure out, well, maybe I didn't rinse this well enough, or maybe I rinsed it too much. Maybe I heated it too hard. Maybe I lost. So you got to think of things that might cause your product to not come out what it should be. Okay? And then questions. There are several questions that you will answer in the student document. There's a bunch of them. There's a bunch of them that I'm going to cross out that you don't have to do. So you'll want to have something to write that down with, so you don't do more than you need to. But the questions can just be copied and answered in the document itself, in your lab report. Okay? So, here's the student document. So there's our procedures, our purpose. Here's your procedures. And like I said, just give me a detailed summary. Here are where you'll start your questions. Okay? So 1 through 7, 8, 9, 10. Okay, so these are the ones you're going to mark out. These are ones you do not have to do. So you want to write this down somewhere, because you certainly don't want to be doing more than you have to. All right. Do not need to do number 12. You do not need to do number 15. You do not need to do 19 or 18 or 20. And you do not need to do any of 22 or the elaborate. Okay? So you can cross out 12, 15, 18, 19, 20, and 22. You do not have to answer those questions. Okay? So when you turn this in, you are going to submit 3 things. When you turn this in, you're going to submit the Google Sheets, you're going to submit the student data sheet, and you're going to submit the lab report. Okay? So on the Google Sheets, hopefully I have shared it with you, but this is all the data. I think I shared it with y'all so you can see it. And it should ask you to make a copy. So you can edit this however you need to. And the video explains how to do everything. So basically what you're going to do is you're going to take these grams that you have here in red, and you're going to change them to moles, just like we did at the very beginning of class. We're going to go grams to moles, okay? And those are the numbers you're going to put in here where it says moles up. I'm just going to make up something. So if we say the first one is 0.1 and the second one is 0.2, then you're going to get the ratio. To get the ratio, you're going to take the smallest number and divide it into both numbers. So 0.1 divided by 0.1 and 0.1 divided by 0.2. So that's going to give us a 1-to-2 ratio. This is 1. Actually, that should be upside down. To 2. Okay? Percent error. To do the percent error, all you're going to do is you're just going to take your ratio, which you're not going to get 1-to-2. You're going to get 1 to 1.5 or something like that. So you'll take your value that you got, subtract from 2, divide by 2, multiply by 100. And that's how you get percent error. You'll do that for all 6 groups. Then you will take your moles of magnesium and moles of chlorine, and you will make you a data table down here with these numbers. So 0.1, 0.2, all the way down. And I show you in the video how to take those numbers and make a graph. Okay? And then you'll make that graph, and that'll be part of your analysis. Okay? Questions? If you have them, save them for tomorrow. The lab report will be can be a Google Doc, because you're going to write up an actual report. Okay? So just you'll follow the rubric that I gave you. Okay? All right. Anything else? Okay, then let's transition to what we have to do today, which actually, let's go to Unit 5. I'm going to make your life a little bit better. So, Unit 5, yes, ma'am.
Is that report going to be like a lab grade or like a test grade?
It's going to be more like a project grade. And it's due, I believe it's due Friday, yeah. But there's nothing in today that has to be turned in today. I think this ed puzzle needs to be done tonight. It shouldn't take you too awful long. And this chemical equations practice I have made ungraded, meaning it's not worth any points. So you don't have to do it today. And I actually don't know how to take the due date off of it. I don't want to do that. Maybe if I just, okay. Well, anyway, it's not due today. What I'm going to leave this on here for is practice for a test. So when we come time to take a test on this, this will be a good thing that you can go back and review as practice, because it has the answers at the back, so you can go back and check your answers, but it is not going to be for a test grade or for any grade at all, okay? So it'll be there, but it's not due for anything. All right, we're going to work on this in class today, but it is due the 8th, and we'll finish this little checkpoint at the end of class today. It's going to cover exactly what we're going to talk about today, which is chemical reactions. So everything, this is why I'm harping on this, because everything we learned in Unit 4, we're going to use here, plus some. We're just adding on, right? Same thing we've been doing, but now we're adding on a little bit more. So in the last unit, we learned how to write formulas. We learned how to name compounds. We learned how to change things from grams to moles or moles to molecules. In this unit, we're going to talk about entire chemical reactions. So in the empirical formula lab, that's what we did. We had a chemical reaction. We took magnesium, we added it to HCl, and we formed a new compound. We saw lots of bubbles and smoke, and it was really cool. But there was a purpose behind it. The purpose behind it was to make a new compound. Okay? That's a chemical reaction, a process during which one or more reactants changes into one or more products. Okay? And we have a way that we write those. It's called a chemical equation, and we write it the same way all the time. You put the reactants on the left. Okay, so you might want to, your notes are in Unit 5. There's a folder in Unit 5 just for notes. So this is what happens before the reaction takes place. We always put it on the left side, and we have an arrow that means yields or means equal. So if you think of this like an algebra equation, the equal side means you take what's on the left side of it, you put it together, you make what's on the right. 1 plus 1 equals 2. Same thing here. We have our reactants, they're on the left. We're going to put them together, and they're going to make a new product that's on the right. And the arrow is like our equal sign. So products are what we make, and they're on the right side. Law of conservation of matter. Law of conservation of matter, first law of thermodynamics, says we cannot create or destroy matter. So if you start with something, you better end up with it. Okay, now it might be different in its form, but those atoms will still be there. Okay, so matter can't be created or destroyed. It can only be transformed or transferred. Okay, so that means, for our purposes, that means in an equation, both sides must be equal. We must have the same number and kinds of atoms on both sides. They can rearrange to make new products, but they're still going to be there. So in ours, we had magnesium. In our empirical formula, we had HCl. So that means on the other side of that equation, I better have magnesium, hydrogen, and chlorine. They can be in a different form, but they better all three be there. And they were, in that you made magnesium chloride and you made hydrogen. Okay? The next thing we have to do is learn how to balance that, because they have to be equal on both sides. If I have one hydrogen here and two over here, that doesn't work. I can't just spontaneously make a new hydrogen and stick over there. I had to come from somewhere. And the same with the chlorine. So we have to balance them. Okay? All right, your ed puzzle that you have for tonight is over this material. So I would download my notes and either print them off or have them split screen so that you can look at your notes while you are while you're watching the ed puzzle. All right, a skeleton equation is an equation that's not balanced. We don't have the same number of stuff on both sides. A balanced equation is when we have the same number of atoms on both sides. Now, just like in math, so if we're in math and I write 2x, what does that 2 mean? It means 2 times whatever x is. What do we call that 2? It has a name. It's called a coefficient. It's a coefficient. We have coefficients here too, and they do exactly the same thing. Okay? So when we're balancing equations, the way to get the same number of atoms on both sides is we use coefficients. Because once we have a formula, we can't change that formula. Okay? So for example, if I have CO2, I can't change that. It has to say CO2. If I change this subscript to CO, do I still have carbon dioxide? No, I have a different compound. So I can't just go changing subscripts. They have to stay constant. But I can change a coefficient. I can put a coefficient in there, and it just like in math, this coefficient means you multiply by whatever it's behind. The same thing here. That coefficient goes for the carbon and the oxygen. Okay? That's how we wind up balancing an equation, is we change the coefficients. We never, ever change the subscript. So once you get your formula written, leave the subscripts alone. Okay? Don't change them. So here's our steps for writing equations. We identify the reactants and products. We write a skeleton equation. We count the atoms and balance each one by using coefficients. We do not change the subscripts. And then this one is the one everybody's going to hate to do. We have to double check and triple check and quadruple check and sometimes more than that to make sure that it actually balances. Because every time you change one thing, it could change something else. So you're going to be constantly going back and rechecking and rechecking and rechecking. We also want to make sure that our coefficients are in the lowest possible ratio. So you got to simplify everything down, just like you do in math. If you have 2/4 in math, we simplify that to what? 1/2. Same thing here. If I have a coefficient of 2 and 4 and 2, I got to simplify it down to 1, 2, 1. Okay? All right. So let's start with some practice. Sometimes they will give you the formula and you will balance it that way. Sometimes they really mean when they give you words and you have to come up with the formula and balance the equation, which is why we spend all that time learning how to write formulas. Okay, so I need everybody paying attention up here. This is new, and we need to be focused right here. So I'm going to change this equation to formulas. So what is my symbol for potassium? If I don't want to write out the word potassium, what do I write? K. So on your paper, what I would do, I would write these on my paper. Okay? You always learn more by doing than just sitting. Okay? So I'm going to write K. What's the formula for water? H2O. We know that one. That one's pretty easy. H2O. And I'm going to make potassium hydroxide. Well, what in the world? How do I make what's the formula for potassium hydroxide? Potassium is K. All right, so we start there. What's hydroxide? One of those polyatomic ions we were supposed to memorize. OH. What's the charge on a hydroxide? -1. What's the charge on a potassium? plus 1. So they balance out, so I just have one of each. KOH. Remember that? We've been doing that for a long, long, long time. And hydrogen gas is H2. And hydrogen is what we call a diatomic molecule. It means it doesn't exist by itself. It forms a compound with itself. H2, N2, O2, and all the halogens. They always exist in twos. Okay? So, there's our skeleton equation. So now we need to start counting atoms. How many potassiums do I have on either side? How many Ks on the left side and the right side? One of each. Okay? How many oxygens? One of each. Good. So far we're balanced. Look at the hydrogens. How many's on the left? 2. How many's on the right? 3. I got to make them the same. What am I going to do? What could I do? Nope. No subtracting or adding. Because these formulas are set. The only thing I can do is put in coefficients. So what coefficient am I going to put where? If I got 3 hydrogens on one side and 2 on the other. I could, and where would I put a coefficient on the 3 side? Well, no halves, no halves, no halves. Can't have halves, got to have small whole number ratios. It's got to be a whole number. If I put okay, well, let's just try it, because that's what balancing equations is all about. It's trial and error. And let's see if it works. So tell me what number you want to put in front of this H2. I'm going to put a 2 there. Okay? So that means I now have 4 and 1 is how many? 5. And on the other side I have 2. Does that help me any? No, not really. So let's try something else. What else could we try? Yeah, when you're doing these, use a pencil. You're going to be erasing a lot. All right, so let's think multiples of things. 2s and 4s are multiples of each other, right? And they're pretty easy to do. So if this was 2 on one side and 4 on the other, it'd be easy, right? Is there any way I can make this side that has 3 be 4? In front of what H? I have to put the 2 in front of the what? Because remember, it's a coefficient. I can't split up a formula. I got to put it in front of the K. So if I put a 2 right there, now that's going to give me 2 and 2 is 4, right? So how would I get 4 on the left side? I could put a 2 right here. So now I got 4 and I got 4 hydrogens and 4 hydrogens. What about my oxygens though? Did I mess up my oxygens? No, because I have 2 there and 2 there. But I did mess up something. What did I mess up? Potassium. So how am I going to fix that? I'm going to put a 2 right there. Okay, see how that works? It's not hard. It's a little tedious. And if you're looking at a worksheet, like you're going to be seeing in a minute, you could possibly let yourself get a little overwhelmed. So just take it one at a time. I would use a pencil. Otherwise, you are going to drive yourself crazy marking everything out. And you're not going to be able to tell anything. So use a pencil. All right, let's try the next one. So give me the formula for sodium hydroxide. NaOH. Very good. Sodium is +1. Hydroxide is -1. They balance, no problem. Sulfuric acid. It has an H. Yes. What else does it have? SO4. That is exactly right. The ick changes to 8. So it's sulfate, which is SO4. What's the charge on the sulfate? Not a plus. What's the charge on the sulfate? Negative what? -2. If it's -2 and hydrogen's +1, how many hydrogens do I have to have? 2. So I'm going to put a subscript of 2. Now, once I get those subscripts right, I don't change that. Okay, the formula for sulfuric acid is H2SO4. That's why we spent all that time learning how to do that. And you've got lots more practice on it. So, all right. So now, what about sodium sulfate? What's the formula for that? NaSO4. Is that it? Look at your charges. It's the charge on the sulfate. Charge on the sulfate. -2. What about the sodium? +1. So I need 2 of them. And we all know the last one. H2O. Okay, let's start seeing if they're balanced. All right, sodium. You can pick any one you want. You can start with any one you want. It doesn't matter. So I'm just starting at the left. Sodium. I have 1 on the left and 2 on the right. What am I going to do? Let's try putting a 2 right here. All right, now let's look at oxygens. So with that 2 in front, I got 2 oxygens there, plus 4 there. What's 2 plus 4? 6. Over here, I have 4, and 1 is 5. What can I do? Put a 2 in front of the H2O. Okay. So now my oxygens are balanced. Let's try hydrogens. This 2 goes with the hydrogen as well. So there's 2 there, and 2 there is 4. And 2 times 2 is also 4. So those are balanced, right? Okay. One more element, and that's the sulfur. How many sulfurs are on the left? How many's on the right? They're balanced. I'm done. Okay. It's the smallest whole number ratio, 2, 1, 1, 2. Can't get any smaller than that. So we're finished. All right. Ammonium chloride. What's the formula? Polyatomic ion, so NH4 has positive 1 charge. And what comes after that? Cl, because it has a negative 1 charge. Okay. Sodium hydroxide, we already did that one. Ammonia. Ammonia is one of those you just kind of got to memorize, like water, because it goes by its common name. And it's NH3 and H2O. All right, sodium chloride. What's that? NaCl. Okay, so let's start with nitrogens. How many's on the left? How many's on the right? No, there's not. That's sodium. 1 on the left and 1 on the right. Okay. Hydrogens. How many is on the left? 5. How many's on the right? 5. Exactly. What about chlorine? 1 and 1. What about sodium? 1 and 1. What about oxygen? 1 and 1. It's balanced. Occasionally, you'll come out with one that's already balanced. Not usually, but occasionally. Okay? All right. We're going to, we'll do one more on this, one more in the PowerPoint, and then we'll do some practice problems. And a little PhET simulation. This is the way I learned to do it because, when I was y'all's age, they didn't have the internet when I was y'all's age. So there was no Googles, no PhET simulations, no cool little things like that to help us. So I just learned it the boring way. But we will do a PhET simulation for those who, it actually is pretty cool and is more visual. So if you're more of a visual type learner. Types of reactions, we're just going to touch on these today. There are direct combination reactions or synthesis reactions where we take 2 things and make 1, right? Synthesize, put 2 things together to make 1. There are decomposition reactions. Oops. And this is where I take one thing and split it into two. There are single replacement. This is what we did in the empirical formula lab, where we take an element like magnesium, we take a compound like HCl, and the magnesium and the hydrogen switch places. And we make two new compounds and an element. We have double replacement reactions, and this is where you have two compounds and everybody switches partners, and you make two new compounds. Okay? I think we may come back to this later at the end. So what I want y'all to do right now is go to fet.colorado.edu, fet.colorado.edu, and go ahead and just bookmark that, because it is a really, really, really good resource for you. And hopefully y'all at home are hearing me and able to do this as well. Fet.colorado.edu. And when you get there, you'll come up to this page, and you're going to scroll down to the little bubble that says chemistry. Scroll down to the little bubble that says chemistry. Are all of y'all okay at home? If you're remote, hopefully you are all okay. Just type in the chat box, yes, no, maybe. That way I can address y'all if you have any needs. So chemistry, click on the bubble that says chemistry. And this is what's going to come up. You're going to go down to the third simulation that says balancing chemical equations. And you're going to hit the play button. And we're going to do the introduction first, and then I'll give you some time to play the game. Like I said, this is another really good study guide for when you're getting ready for your test. Come back and play this game. And it'll give you good feedback on how to balance equations and stuff. All right, so the first thing you got to do with these is you got to tell the computer that you have at least one of everything. So do the up arrow. And then go over here to Tools, where it says None, hit the little scales. So we want all those things to be even. Right now, the nitrogens are blue, and we have 2 on one side and 1 on the other. We want them to be 2 on both sides. So what should I do? I'm going to add another one on the right. I'm just going to take my arrow and I'm going to go up so that I have 2. So you can see our little scales are balanced for nitrogen. But what happened to the hydrogen?
It's all messed
They are all messed up. I got 2 on one side, 6 on the other. So what should I do? Add what? Add 2 to the left side? Yes. So that I have a total of 6. Okay? All right, so now try water and combustion on your own. And when you get those 2 done, go and play the game. You can start at level 1, 2. I suggest 1 or 2 to start with. And we'll spend a few minutes playing this, and then we'll come back. Okay? But you don't forget, you have to tell it one of everything first. It's going to start out with 0, and 0 means literally nothing there. So you can't have that. Okay? Okay, so it looks like everybody at home is doing fine. All right, great job. Okay, so just play around with these. Do water, do methane, and then go and play the game. So go back to the home, or down here at the bottom where it says game, click on that, and play a couple of rounds of that. It does ding when you get it right or wrong. It gives a sad dinging sound when you get it wrong, or annoying, one of those sounds. Oh. Why not? Why can't you believe you're getting it right? You're good at it.
I already did all 3 of them.
This is not.
Wait, I want everybody to hear that I'm getting it right.
Now that you know this is not a problem, we just need to work on the grams to mole stuff. You will have this unit Now Pat.
So how do we do that live report? So we just write basically directions on
Follow the rubric, and everything that's in that rubric, you need to include in your.
I know we have to do a little sheet down at the little
Figure out.
Excel sheet or whatever.
That's actually a good question. Let me see if I can find an example lab report from my AP class and show you what that looks like.
I'm kind of confused.
Okay. Give me a second. When did I make them do that is the question. Alright. I think it was last. Okay, I'm gonna stop presenting at home for just a minute because I'm sure my AP kids don't want all their grades broadcasted everywhere.
It's kind of sucky.
Okay, so somebody was asking how this is supposed to look. This is one of my students from AP. They did a lab report. They used the same rubric. It's the same basic steps. So you can see he's got his name and the date and the title here. He has his purpose. He has his procedures. They're listed out, but they weren't the exact copy from the student data sheet. So he listed them out. He has his data. Like I said, with yours, it would probably be easier for y'all to just put a link to the Google Sheet. And put it in the paper so that I can click on that link and it'll direct me to the Google Sheet. That'd probably be the easiest thing. But if not, you have to have the data in there. So you'll have to put it in as a table if the link doesn't work. Here's all of his calculations. So they're doing grams to moles and so on too. And he just listed all of his calculations out. Here's his conclusion. Discussion of theory. His error analysis, so he did his percent yield, and he gave me reasons for why it didn't give as high a percent yield as he thought that it should. The stirring rod, we used the stirring rod to dissolve the salicylic acid, and most likely some of it rained on the rod or something like that. So he gave me an explanation for his error analysis. And then here are all the questions that were in his student document, his student data sheet, the lab sheet, and he answered all of those questions here. And that was it. And he got 100. Okay, so that's kind of what you're going to be doing. Does that make it a little clear? A lot of it is going to be almost cutting and pasting, not exactly, but almost cutting and pasting. It's not like writing a creative writing paper where you've got to come up with this topic and come up with all this stuff. It's all right there. You just got to.
Just like the data, that's
the data sheet. Yeah, just put a link. So here's your data sheet. Just get the link for this and copy and paste it into the document. You know, when you have a Google document, you can go to Insert in the Google document, go to Insert and Link, and just put it right there. Remember the ones you don't have to do. Okay. All right, so everybody got the 3 in the introduction done? Should be at the part where you're playing the game. What you're gonna find on these is, most of them are not too awful bad, but I will go ahead and forewarn you, when we get to combustion reactions, combustion is when you burn something, when you take a hydrocarbon, like gasoline or something, and you burn it, those are awful to balance. They just are. They're doable, but they take a lot of time, they're tedious, and you will be erasing a lot, okay? They're just harder. From the balancing standpoint, they're harder. From the predicting products, which is what you'll eventually be doing, is predicting products, combustion reactions are super easy, because they always make the same thing, carbon dioxide and water. So, from that point, it's easy, but they are hard to balance. Y'all okay back there? Yeah.
Wait, is this one? I don't get a scale.
What do you mean? No, they don't, but they do give you the little levels, so you can count them. But yeah, the scale, you're moving up, you're more advanced than needing a scale. Now. Remember, if you have anything that you have to make up for me, then that has to be done on Wednesday as well. If you have quizzes or anything that need making up, you'll be doing that on Wednesday.
I am very.
Yeah, I don't know how you would have to go. Oh, we got about an hour. So 70%. 7 out of 10, 7%.
I got one on there.
Then you're gonna love the check one at the end of class.
Yeah, no, this is not.
You're gonna love the check one. You gotta be careful. What? Huh? Yes, level 3s are hard. There's a combustion reaction. I did that one this morning, and it's rough. I will tell you on those, think about least common multiples. Like usually you'll have odd numbers, like 7 on one side and 2 on the other. So think about a common multiple between 7 and 2 would be 14. So try and get 14 on that side. And then you'll have to double everything else, but. No, that's not a combustion reaction, so you don't.
Okay, I just have to finish number 2. Number 2.
All right, lunchtime. So after lunch, we'll start back with,
I just now finished.
as far as lunch goes, please make sure that you move your Chromebook out of the way and that you don't have an open container right beside your Chromebook.
Yeah.
You gotta eat at the table, but try to be careful with it. Okay, so let's pause this.
Confusing. It's about the length of the dress. Is it?
I know, but then it's not, yeah. Thank you. All right. Okay, so we have played around with the FED simulation. Like I said, make sure that you bookmark this so that you can come back and use this as a really good study tool when it comes test time or quiz time. All right. I think what I want to do, I think what I want to do is I want us to go ahead and do our checkpoint, because I don't want you to run out of time too much. So let me tell you a little bit about that checkpoint before you get started on it. Hopefully everybody is back. Looks like everybody's coming back that's at home. So I'll give them a few minutes to get back on here. With the checkpoint, which we're going to take in a minute, I know y'all are going to flip out about this, but it's okay.
Oh, no. When Ms. Kevin
Well,
says that,
especially
you know,
one person's going to flip out of it. It is timed. Now, the reason being is that, you have to get used to a time test. Your ACT is a time test. If you take AP, the AP is a time test. You got to get used to being on the clock,
How long
okay?
is the ACT?
Now,
How long is the ACT?
ACT overall is 3 hours, but they break it up into, English and math and science and whatever, and they give you anywhere from, I think the science portion, I don't know why, it's crazy, it's only 35 minutes long. What?
Losers.
I know, and they always put it at the end when you're tired. But anywho, they should make that one the first one. But anyway, math is like 45 minutes, English is like, I don't know, 30 minutes, and there's a reading, there's a whatever, okay? So, the point being, you need to get used to being on the clock. So, this checkpoint is timed, but it's 5 minutes, but it's an easy question, okay? It's not a difficult question. As long as you are careful and look completely at your answer choices and make the best possible answer choice, okay? You will have to use your lockdown browser. It is on the lockdown browser. So you can go ahead and sign completely out of your Chromebook if you want to, and go ahead and set up that lockdown browser and get that going. So if you are at home, that means if you're on the lockdown browser, of course, it's going to boot you out of the Google Meet. And then you'll come back to the Google Meet when you are done with the checkpoint, because we do have a few things that we're going to talk about at the very end of class, okay? So remember, for the lockdown browser, you'll sign completely all the way back out of your Chromebook, right into the original sign-in, okay? So you'll sign completely out of your Chromebook. In the app section on the left-hand side, you will go to Lockdown Browser, and that's all it says is Lockdown Browser. When you get to when you click on Lockdown Browser, it will ask you for your institution. Your institution is Morgan County Schools. Then it will direct you to sign in with your school email and password. The key, every time somebody has problems with this, it's one problem. You didn't sign out of your Chromebook. You have to completely sign out of the Chromebook. Okay? Sign out as a user and everything. And then come back in. Do the apps first, then come back in. Okay? All right, so those of you at home, go ahead and give that a whirl. It is Unit 5, Checkpoint 1. Do what? Not on this one. I'm not making a huge deal about that on this one. No. I wouldn't worry about it.
They're not gaining.
That's true, they're not.
Looks like why.
They're not. And I always know when y'all think we don't know when somebody's done stuff like that, but we do.
I bet they.
There's not always stuff we can do about it, but we know.
I bet they got a better grade than I could try.
Well, I think you're going to find in life that when people take shortcuts and it seems like they're getting ahead, they're really not. No, I wouldn't start just yet. This is one of those things where it's going to benefit you.
Oh.
All right, so here is the question. I'm going to put it up here. You can go ahead and go through your whole lockdown browser issues and stuff. This looks like a big, hairy, awful question, but it's not. Okay, all they're wanting you to do is pick which one of these four has been correctly written and balanced. Now notice what I said, correctly written and balanced. You can ignore all of the AQs and the S's. They don't do anything for balancing the equation. So you are going to choose which one is balanced correctly and written correctly, where the chemical formula is written correctly, and then it's balanced correctly. And ignore the AQs and the S's. Don't worry about them. Okay? So it's not a terribly hard question. And you do get points even if you get it wrong. So you have 5 minutes, and once you hit start, 5 minutes starts. Yes, you may go. So pick out which one is written correctly. Talk a little bit about synthesis reactions. When you watch the Ed puzzle tonight, you will see synthesis reactions, and you'll see this presentation. All right, so there are a couple of rules that some things are going to just make logical sense. You put these two things together, then this is what you get. Some things might not make logical sense, and so you might want to memorize that rule for what you always get. So if we are always combining a metal with oxygen, like you see here, we always get the same thing. We always get a metal oxide. So we get the metal plus the oxygen stuck together. If those are the only two things you're adding together, then it's logical sense that you get a metal oxide, right? That's all that's there, okay? The same thing with the sulfur. If we react to metal and sulfur, we get a metal sulfide. Not too complicated. For halogens, if we react to group 1 with a halogen, we always get what we call a metal halide, or we say halide because it could be a chloride or a bromide or an iodide or something like that. So again, those are the only two things that are in there. So of course they've got to come together and make that one compound. To me, that makes pretty good sense. If not, you can memorize each of these rules, but the less you have to memorize, the better, because then you wind up forgetting it. So the more you can figure out, the better. So if we have a group 2 metal, it does the same thing, but notice that you've got to get your formula right. And with group 2 metals and halogens, you're going to have the subscript of 2. So calcium and chloride together would make CaCl2, because calcium's a +2, chlorine's a -1. They have to balance. So you got to have CaCl2. Okay? Now this one, to me, this one's a little confusing. So I would memorize this one. And this one's confusing. So I would memorize this one. To me, these are a little harder to just intuitively figure out. All right, so if we take a metal oxide and react it with water, we always get a metallic hydroxide. So if I had magnesium oxide and I react it with water, that's going to give me magnesium hydroxide. Okay, magnesium is a +2, hydroxide is a -1, so I have to have 2 of them. That happens for all of them. If it's sodium, if I had sodium oxide and I react it with water, it's going to give me sodium hydroxide. If I had calcium, it's going to give me what? If I had calcium oxide and water, it's going to give me calcium hydroxide. All metals, all metal oxides, we add them to water, they give us the metallic hydroxide. Okay? So when you're asked to predict an equation, because a lot of times that's what I'm going to do. I'm going to say, all right, we've got lithium oxide, and water. Tell me what the products are. That's going to be your problem. And you're going to have to remember that, okay, it's a metal oxide. I'm adding it to water. It always gives me a metal hydroxide. So my answer would be lithium hydroxide. And then you balance the equation. Okay? So that's how these questions are going to wind up presenting themselves. The other way they'll wind up presenting themselves is, all right, I'll say, okay, I have, what type of reaction is this?
Good afternoon, Pikeville High School. Please stand and pledge. Attention, salute, pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. SBLA virtual meeting is this Wednesday at 11 a.m. Technology and routine to the employee information. Attention, rising juniors and seniors. If you are interested in starting your own company, Decatur Morgan CEO is now accepting applications. For additional information, look for the email from Ms. Kennedy. Cap Gown, Castle Diploma, and Diploma Cover came to light today. It's this Friday, February 5th, 11 to 11:30 in the cafeteria. Thank you and have a great day.
So the other way that this question might present itself is I'll say, all right, here's a reaction. Tell me what kind of reaction it is. So you have to determine, is this synthesis, is it decomposition, is it double replacement, single replacement, whatever. I have two things becoming one. Two things becoming one is always synthesis. That's it. That's your answer. And your justification would be because I have two compounds combining together to make one new compound. That's always synthesis. Okay? All right, so watch the Ed Puzzle tonight. Come to the Google Meet tomorrow with a question. Work on the test corrections for 16 through 21. Work on your formal lab report. And we didn't get to the balancing equation sheet, but it is due on Monday. So we'll spend a little time Friday going back over it. It's basically the same thing we did in our examples. I knew there was something we were missing. So did everybody figure out where you may have messed up on your test? You know what you did wrong?
I used 6.022.
Ah, yes. That's how many, not the mass. That's how many there would be. So it could ask for how many atoms. You're eventually going to have to use that. But you got to eventually. You can't go directly from grams to atoms. You got to go moles first.
More. I don't